Hello students, this presentation is classifications between one-way and two-way analysis of variance is presented by 60 thoughts. Students, after watching this session, don't forget to click the bell icon to get the new information. So what is today topic? Today topic is classification of one-way and two-way analysis test. So here there are two type of classifications are there. First we see what is one-way classifications. In one-way classifications, the observations or experimental units are classified according to one factor of interest. For example, we consider a yield of several plots of land may be classified according to fertilizers or seeds. Okay, so here we take into account the effective of only one variable, which means only one factor. But in coming to two-way classification, we take into account the effective of two variables or two factors can be studied. Okay, which means we consider one classification along with column wise and the other row wise. For example, a yield of crop in a several plots of land may be classified according into a different varieties of seeds and fertilizers. So here seeds and fertilizers are two different factors. Okay. So here you see the procedure of analysis in two-way classification is total both on columns and row. The effective of one factor is studied through the column-wise figure and total, and the other is row-wise figure and total. The variance are compared with the residual variance. Otherwise, the variance are compared with what the error. Okay, so next we will discuss what is one-way classification of ANOVA table. So here we consider five different categories source of variation. Another one is sum of square, it is denoted by SS. And third one is degree of freedom, it is denoted by DF. And fourth one is mean square, it is defined by MS. And last one is variance ratio, that is nothing but F test. In one-way classification, we consider only one factor, that is column wise. So that is nothing but between column wise. Sum of square, it is denoted by SSC. What is the meaning of SSC? Sum of square of between. Degree of freedom is C minus 1. C is nothing but number of columns. For example, the given data having 4 columns means C value is 4. So 4 minus 1 equal to 3. And the mean square is nothing but MSC. MSC is nothing but mean square between columns. That is nothing but SSC by C minus 1. And next we find within errors or within residual. What is SSC? SSC is nothing but sum of square of within errors. Degree of freedom is n minus c. N is nothing but total number of given observations. MSC equal to SSC by n minus c. Next we find the F value. How to find the F ratio? If MSC greater than MSE, then we consider F equal to MSC by MSC. Otherwise, if MSC greater than MSC, then we consider F equal to MSC by MSC. Okay. Listen very carefully. In your F test, final answer it should be greater than 1. Suppose you get F value is less than 1, we are unable to proceed a variance ratio test. Okay. And the degree of freedom is C minus 1 comma N minus C. Otherwise, DF equal to N minus C comma C minus 1. So note, since the value of F should be greater than 1, compulsory we should get F value is greater than 1. Otherwise, your ratio is wrong. Okay, that means your calculation is wrong. So now we see the meaning of one-way classification parameters. So first one, N. N is nothing but total number of given observations. Second one, capital T. Capital T is sum of all the observations, which means add all the observations, we get T value. Third one is C. C is nothing but number of columns. In the given data, we have some columns are there. So that values. Next one, correction factor we have to find, which it is denoted by CF. CF equal to T square by capital N. Next we find SST. What is the meaning of SST? Sum square total. That is equal to sum of xi square minus T square by N. Adding all sample square values, sub minus correction factor value. Next, we find sum of square of between columns. That is nothing but sum of x1 whole square by n1 plus sum of x2 whole square by n2 plus etc. minus t square by n. So here, what is sum of x1 whole square? That means we are going to add all values of in sample 1 and divide number of sample values in sample 1. Similarly, adding all values in sample 2 and divide total number of values in sample 2. That is called n2. n1, n2, n3 is nothing but sample size. This is sample size in first one, sample size in second one, and third one, and etc. Next, we find sum of square of within errors. That is equal to sum of square of total minus sum of square of between columns. Subtracting these two, you get SSE. Okay, next one, classification of a two-way ANOVA table. So here also we consider 5 different categories. What is difference between one-way and two-way means in two-way we consider 2 different factors. So additionally, we in one factor we consider between columns. Whatever we in one way between columns, same formula here. And second factor we consider a row wise, that is between rows. Okay, what? So between column SSC C minus 1, MSC equal to SSC by C minus 1. This is nothing but variance ratio in column wise MSC by MSC, otherwise MSC by MSC. Okay, whatever we studied in ANOVA test 1, same meanings, same parameter we write here. Okay, similarly we write between columns. This is only new parameters for two-way classification of ANOVA test. Okay, so you consider sum of square of row wise. Okay, that is called SSR. So R minus 1. R is nothing but number of rows. MS, how to find MSR? Divide SSR by R minus 1. Find the variance ratio in row wise. Okay, so that is nothing but MSR by MSC. If MSR greater than MSC. Suppose your MSC is greater than MSR, so we consider F ratio test in row wise. That is equal to MSC by MSR. Okay, so next we consider within errors. What is within sum of square within error? That is denoted by SSC. Degree of freedom is C minus 1 into R minus 1. MSC equal to SSC by C minus 1 into R minus 1. Finally, adding total values. That is sum of square of total equal to, if you add these 3 values, you get a SST value. Next, adding these 3 values, you get RC minus 1. First, you multiply these 2, you get one answer. After that, adding these 3, compulsory you will get RC minus 1. So this is the this is called two-way classification of ANOVA test. So here the very important point is since the value of F ratio test in column wise and row wise, it should be greater than 1. Okay, otherwise it is wrong. So that we take the larger of MSC or MSC and MSR or MSC. Once you get larger value in the numerator, then only we will get what? Yeah, greater than 1. Suppose you get lower value in numerator, get a less than 1 or a 0 less than 1 only, so that we take larger value in numerator. Okay, so this is the very important point. So next we see the meaning of a two-way classification parameter. So here n is nothing but number of observation, t is sum of all observation, third one c is nothing but number of columns, r is nothing but number of rows, and the correction factor it is denoted by CF, same formula t squared by n. Next SST, whatever we studied in ANOVA test 1, same formula we consider here. SST equal to sum of xi square minus t square by n. Next we find the sum square of between columns, same formula, sum of x1 whole square by n1 plus sum of x2 whole square by n2 plus etc. minus t square by n. So this is nothing but adding all sample values in column wise, okay, by number of sample size n1. Similarly, we find SSR. This is new formula. Okay, what is SSR? Square between row wise. So we consider a formula is sum of y1 whole square by n1, sum of y2 whole square by n2 plus etc. minus t square by n. So here, now what is the meaning of sum of y1 means we are going to add all values of in sample 1 row wise, not a column wise. We are adding row wise and number of values present in row wise of sample 1, that is called n1. So here this n1 and this n1 are not equal. Okay. So this is called, if you add a column wise, you get n values some different number. Here, if you add row wise, we get this n1, n2 are different values. But all values are called what? Sample size only. This is sample size in row column wise. This is sample size in row wise. Next, we find a sum of square of within error, that is equal to subtracting total value minus column minus row wise. Okay. So I hope you are enjoying this session. Thank you.